All right. So we had pretty interesting results last night, right?
Yeah.
We should be, we should be pretty proud with what we saw. Don't worry about first 4 games, but in the last one, I was pretty impressed. We took 1+2, right? I know there are improvements that need to be made. Okay, we will get better by states. There is no doubt about it. I have no doubt. So, but before we go and talk about, brainstorm the changes that need to be made, I want to start with one quote. There is a guy named Kent Beck. Okay, Kent Beck is a pioneer in software engineering. He's the one who invented the whole concept of test-driven development. I don't know, I should call it invention or discovered, right? Test-driven development. He's a big advocate of test-driven development. And there is another one in Java frameworks called JUnit. Okay, JUnit is a unit testing framework. So this guy wrote that unit testing framework while traveling on a plane. So his name is Kent Beck. Kent Beck is one of the pioneers in the entire software software industry. So he says this, okay? This is his quote. I want you to pay attention. First, make the change easy. First, make the change easy, and then make the easy change. So let me explain it to you. So first, make the change easy. So whatever you are working on, first refactor it. Change it in a way that it's easy to change. Anyone can come and change. And then, of course, come and make the easy change. So that's the making the easy change. It's always easy because changing the program in such a way that it's more readable, anyone can come and make the change. That is where you need to spend a lot of time. That is the power of refactoring. How many of you understood what I just said? Yeah, did you understand? So let's spend time on the first step here. Okay, I mean, you can make the easy change anytime. Once we refactor our code in such a way that it's so easy to change. Does it make sense? So let's do that. Let's make our changes easy. So what I mean by that is, let's look at the code and then make all the improvements and refactor it. Okay. My goal in the first pass, probably good hour and a half we will spend here. We will not make any functional changes, because when I say the refactoring definition is, it's improving the design of the code without changing the functionality. Does it make sense? So we don't want to do that. First see if our code is healthy and it's in good shape, then we'll make the easy change. If you guys follow, say aye. Yeah, do you guys follow what I'm saying here? Okay, let's do that. So I just did a git pull, so I have it, and then the code. I want all of you to contribute actively. So I don't care about the background noises, so go ahead and unmute yourself. Okay, so this is the class. This is our main class, right? Okay, I want you guys to actively participate. Is this big enough, the font? You want me to increase it? Guys, is this big enough or you want me to increase it?
This is good.
This is okay. Okay,
Uncle,
can
can you pull again? I think this is a little, because I just pushed something.
Oh, you just pushed it. Okay.
Yeah, I changed some stuff this morning.
Oh, okay. So
some of the examples that the team is giving in our, I'll share this presentation. Maybe I don't know how.
hey, Sia, do you want to mute yourself?
Useful, yeah. Not useful, but
yeah. Okay. So this is the red right. This is for the states, and by the way, looks like this is work. This should work for both. This red right should work for blue also, right? We will get to that in a second, later. But let's go here. We will, in the first pass, let's go, we created all these runnable, runnable threads, okay? And then once we start here, this is, I think, I'll go here directly. After we start, we get the parking position, and then we are creating the threads and then doing it, right? So elevator thread, thread, follow the trajectory, and then you're dropping the before release and then release the preloaded cone. Sure. And then, oh, is this what you added? Lift before release?
Yeah.
Lift before release. Is it after release?
Before release. Ooh, I think we need to rename that.
That's okay. So that's why we are here. So let's understand this method. Do you want to explain, Rishi?
Yeah. So the idea is when we're dropping the cone, we go down and then drop, but we saw that it would kind of stay with the cone, and like yesterday, it would just pull the cone out. So what the idea is that we go down, we drop, and we pick it back up. Just so then we have that little shaking motion, just so then we disconnect from the cone. So we don't have the thing that happened yesterday where like it would just keep the cone going when it moved.
Okay. Fantastic. Any objections on that? So this one, the only thing we want to say lift before, this is after release. So let's rename that. So this one, we'll call it lift after release. Okay. So after cone is released, we want to raise it. That's what Rishi start here. So you take from elevator, you get the current ticks, and then you current ticks and then tick lift before release. This one also, he's raising 100 ticks. This one also, let's refactor and rename it to tick lift. You want to call it plural ticks? Is it okay?
Yeah, actually, yeah.
This one also, I'll change it to ticks. Okay. Okay. So lift after release, you're getting the current number of ticks. Let's say the elevator current ticks is like 700 as an example. 700 plus this is another 100. If you mouse over, it will give you the value of this particular constant, another 100. And then you're changing the target position, and your mode is run to position. And you're at full speed, you are bringing 1.0 is a full speed. At full speed, elevator is going up. If it's busy, sleep for 25 milliseconds. So what it means is it takes some time to go to this plus 100 ticks, right? So the elevator will be busy until that point. This. So okay, now let's go back. So now if I want to go back, the way I do it is Control Alt and then left arrow. Control Alt left arrow. I go here and then left arrow. Yep. So this is where we started. So wait for start, and then initial drop is done. Grab dot release. This lift after release, we do it. So lift after release, we do that so that we can start doing additional cones, right? So did you guys understand? These lines of code are essentially the job here is to drop the preloaded cone. Get the parking. Of course, just parking. Getting the parking position is just storing in a variable. That's all, right? And then we create 2 threads. Essentially, we start 2 threads: elevator thread and arm thread, both. And then the main thread will be doing the follow the trajectory. After that, you drop a bit, and then release the preloaded cone, and then lift after release. Okay. Any questions on this one? I don't have any questions. Okay. So now let's go to the interesting part. This is where we want to make it better, right? So first additional cone start. So you want to, before, after dropping, you are actually sleeping for 100 milliseconds. So we will get back to it and see if it's enough. Through testing, we'll find out, and we can always do that. But after dropping, we are starting slider thread, elevator thread, arm thread, and then we see if these guys are done. There is a better way to do that. I will show you, but that's not the point here. Sleeping, start all these threads, and then arm.go home, and then elevator going to the stack pickup, sleep, and then pick up. Okay. And then, of course, once you pick up, reduce the number of cones in the stack. Okay. So all of this you have to repeat. We are repeating the same code probably 4 times. Do you guys agree? I think, if I'm not wrong, this is the first additional cone start and first additional cone end, right? So, and then second.
Well,
Go ahead.
actually, it's still the fast cone. It's just now dropping the fast cone.
Oh, yeah, I'm sorry. My bad. Yes. So we only picked up here, guys, kids, you need to give me that. So thank you, Rishi, for that. So you pick up and then sleep for 400 milliseconds, and then you start your threads, and then you release it. Okay, and then lift. First additional cone ends here. So we are this whole code here, first additional cone start to end, these lines of code, I don't know how many lines of code. This one we are repeating. This is second additional cone start.
Can't we just loop it?
Exactly,
Make it
Anish.
just go down.
Exactly,
like,
Anish. That is the
instead of
thought.
Okay,
Yep,
but we
yep.
still have to make it go down, because once you take a cone out from the stack, we have to lower the elevator more.
Absolutely, Anish. Absolutely. That's the thought process. So great point. Yes, we will. So I want to loop this one, but so how can I loop this one, guys? If I want to take this out, what do I do in Java? I want to put all of this.
You can do like a while loop. So while X is like less than, while cones left and cone stack is less
Sure.
or greater than 1.
Or if I know, no, I like that. I like that thought process, Vishal. But before doing that, what do you do with this cone, with this line of code? Do you want to? This is a reusable block of code. I want to reuse it 4 times. for 4 cones. What am I saying? This is a block of code. I'm saying I want to name this block of code. Come on, you guys know this. If I
Create a
want to
function.
name this block of code, what do I do?
Make a function.
Exactly. Who said that?
Me.
Madhu? So you call Madhu, is that you who said that?
Yes.
Yeah. So that's a function. In any programming language, that is function. In Java, what is functions equivalent? What is it called? Function. In specifically, there is a name for that. Yes, that's called method. So you create a new method and then repeat this method. Call this method, 3 times if you want to pick up 3. 4 times if you want to pick up 4. Of course, later you can optimize that one also and then put it in a loop, as Vishal and Anish were saying. But first thing is, let's put this in a method. Okay. And shall I say something else now? We have 2 options here. I want to create a new method and dump all of this in that method. Okay. But I feel this class is doing way too much. This read write is not manageable. Okay. We initially wrote this one, just Rishi and myself, as a first first pass. Now it's getting out of control quickly. So I want to refactor this. I want to remember I told you guys I want to make that change easy first. Okay. What I mean by that is not only create a separate method, but I'll put it in a separate class. All the functionality around picking up and dropping the additional cones, I will put it in its own class utility. Okay. I will call it, are there any good names? Additional cone dropper or something like that. Does it make sense what I'm saying, guys? Can you say yes if you understand?
Yes.
Yes.
Yeah.
Okay. So let's go ahead and create a new Java class. And at this point, I'm thinking it's additional cone dropper. Okay, but you can suggest me a name, or we can refactor anytime. Additional cone dropper. Okay. And refactoring, you must do it all the time, not one time, because you have to improve the code quality. Code quality is very important. And programming team, this is what, when you guys talk to judges there, okay, I want all of you to say this. Hey, look at how beautiful our robot is. It's not just that not just our robot is beautiful. Our code is equally beautiful too. We continuously refactor to make it beautiful. Okay.
On Saturday,
to make it more manageable. Yes. What is that?
on Saturday, when the coaches told us
Yes.
to talk about the code being neat and organized.
Absolutely. It is modular. Okay. We have we have different objects. This is true object-oriented programming. Okay. And you are practicing clean code principles. I'll talk to you guys, separate class. I'll talk to you guys about it, what to talk there with the judges and all. Okay. But anyways, I'll call this additional cone dropper, and my method name, I'll say, drop additional cone, pick and drop additional cone. Yeah. Can I do that, guys? And then we'll find out what it is. So pick and drop an additional cone. Pick and drop additional cone. Yeah, this is good. So now let me start. So from this point onwards, first additional cone start to first additional cone end. Okay, all of this. There is a There is actually a better way, but I'm intentionally doing it manually. I will share with you why I'm doing it. Because I want to move a lot of things from that class to this one. Okay. So this method's responsibility, in fact, this class's responsibility is to pick up and drop additional cones. Okay. And this method's responsibility is to do that. Every time you call me, I know everything. I know how to go to cone stack, pick up a cone, and then drop. I will do everything. You don't have to tell me what to do. I know everything around it. Does it make sense or no? So all these are, there is no method called sleep. So what do? We will fix each one of them. But first, let's talk about. So let's go from here, guys. First, there is no sleep method. Huh? Okay, no problem. Let's do let's go to elevator. I think in elevator we wrote that sleep function. So I will write one private method called sleep. Okay. So this thread will sleep. There you go. My sleep is good. This function, this method exists now. Wait for after drop. This one, it is an error. It is throwing cannot resolve symbol wait for drop. Hey, I don't know what you're saying. There is no variable called wait for drop. Okay, let me go get that wait for drop. Wait after drop, or what is that? Wait after drop. Okay. So this variable, let's go. I cut that and put it here. Okay. So wait after drop. This line of code is good. And now it's saying, hey, there is no thing called slider thread for stack pickup. I don't know what it is. I want to move that guy also into this one. Slider thread for stack pickup. Slider thread for stack pickup. This guy. And then what else? Elevator thread for stack pickup, ARM thread for stack pickup. Elevator thread for stack pickup and ARM thread for stack pickup. All these three runnables, I'm actually moving them here. Okay. And of course, we will make this also better, but bear with me for a second here. Okay. Oh, I don't know. So here, when I try to do that, it's saying slider dot fully extend. I don't know what is slider. Okay, no problem. So we need to do a slider, right? I'll create a variable called slider. Yeah. Private slider and then slider. Yeah. And then I'll create a new constructor here. Public additional cone dropper, and then someone will actually private slider. I can do a new slider here itself. Let me see if I need a constructor or not. Oh, slider needs a hardware map. Okay. Now my additional cone dropper needs, I need to take hardware map, guys. So I'll say hardware map. Now I will. So first, let me get the hardware map and store it in a variable hardware map. Okay. So I'll say this dot hardware map equal to hardware map. Essentially, I'm taking this variable. I'm taking this hardware map. You pass me the hardware map, and then I'm storing it in this variable. That's all I'm doing. After this, now I will create a new slider. Slider equal to new slider and pass hardware map here. That's it. So I got a new slider here. So slider dot fully extend. Oh, I don't know what I don't know this variable called slider thread working. Okay. Slider thread working. I will remove this variable, guys. There is a better way to do that. I will explain that to you guys. And then I don't know what elevator is. Okay, so no problem. Let's get the elevator. Private elevator, elevator. And then elevator equal to new elevator of hardware map. That's it. I got the elevator. Elevator is good. And now I'm removing this line of code. I will find out, I will tell you there is a better way. And then we need arm. We need three things: slider, elevator, arm, right? Private arm, arm. And then I'll say arm equal to new arm of hardware map. That's it. So I got arm. Now I remove this one also. I've found there is a better way. Okay, guys, there are three runnable. Can one of you tell me? I will unmute one of you and tell me what this meaning is. Can one of you tell me why we need this? I'll ask Sia. Try your best. Okay, try your best. Why did we do this? We started 3 threads here: slider, elevator, arm. After the initial preloaded cone is dropped, we started 3 different threads. Okay, and then we are checking something here. Are you what is this? While elevator thread working, slider thread working, we are sleeping here. What is the idea?
I think while the elevator thread is working and while the slide, like after both of them are done, you sleep for 50 milliseconds.
You're saying after you are done, you sleep? This is while elevator is working, while elevator is working or slider is working, sleep for 50 milliseconds. Jitin, can you try? But you really attempted it, Sia. Good job. Super proud.
Well, both.
Say that again.
While both the threads are working, one of them has to sleep for 50 milliseconds.
One of them? Who is sleeping here?
Hello?
Hello? Hey, I'm here. Who is sleeping here? You said one of them has to sleep. I didn't fully get you there. Who can take? Anyone else can attempt to explain to me, or everyone in the group here?
So while both the elevator and the slider working, we're sleeping to prevent the arm from moving.
Wait. Is this and while elevator and slider? Is it what's the symbol? This one here, the one I highlighted. Or while go ahead.
Elevator or sliders, if either one of them are working, we'll sleep for 50 milliseconds. And if
Why do we sleep? Why do we sleep for 50 milliseconds if either of them is working, Anish?
Wait, say that again.
Why are you sleeping for 50 milliseconds when either elevator or slider is working?
Because we don't want to get caught in the arm.
Right. Yeah.
That's why we want both of them to be done before we start moving the arm.
So that's an excellent point. So what you guys are saying is, Vishal, is that what you are also saying?
Yeah,
Vishal, do you want to add?
He said thumbs up.
Oh, okay. Thumbs up. Okay, good. If you want to add anything, Vishal, you can add.
No, that looks like everything.
Okay.
It sounded like everything.
Right. So while this one is working, so guys, I want you to understand one thing here. These three things are happening in parallel here. Okay, these three things are happening in parallel. What are the three things? Slider is going to pick up. Elevator is raising, raising or dropping, whatever. Elevator is doing its job for stack pickup. Okay, and ARM is actually doing for stack pickup. We want, we want to be as efficient as possible. That is why we spun 3 threads here. When 3 things are going in parallel, we do not want to start the process of picking up the cones until all these 3 are done. Does it make sense or no? Otherwise, we will go out of sync somewhere. Guys, are you with me?
Yeah.
Okay. Fantastic. Now, so this is a small modification I want to make here is, hey Rishi, why are we only doing why are we looking at only elevator and slider? Why are we not looking at ARM here? And then why do we do this ARM?
Oh, I think the way I was testing something, I think I forgot to delete it, but the way that the ARM works is that it doesn't need its own thread to do it, because I think it has its own thread kind of system. But when you tell the ARM to go to a position, we don't need to wait for it to finish. It'll just keep going to the position. And yeah, because
But
It-
go ahead.
it doesn't
Go ahead.
change anything. Because the second it says go to position, it's just gonna say that it finishes.
Right. So
The arm.go home can get deleted. But I
So-
think we were having some issue where it wouldn't. The arm, like, I'd send it to telemetry or something, and the arm just wouldn't give the proper thumbs up signal.
because ARM needs to, I think ARM, we are never waiting for thumbs up here, buddy. So let's go take a look at it here. Okay, ARM thread for stack pickup. Okay, so let's
Yeah.
take a look at this guy, and then what it's doing is ARM.go home. Okay, so see this one. ARM is only doing one thing. ARM.set position. It is not waiting. That is the problem.
Ah,
This is not waiting. You need to wait this guy for, because when you say that, that is the difference between your DC motor and what's the other motor? This one,
Servo.
the servo. So servo, you can give instantaneously what that position is. It will take its time, but you don't want to. You have to sleep actually, okay, until it goes to its position. So my recommendation is we must sleep here, meaning we want this thread. Who owns this thread? This guy owns this thread. This thread, we will have ARM guy to sleep for a second or so, and then we will put that guy also here in the while loop. So if ARM is in the working, if ARM thread is working, meaning if it is in the middle of sleep, okay, then we will not do it. We will wait for all the 3 things to be done. So if you say that, hey, ARM takes 2 seconds to go to its home, then we can sleep for those many seconds or those many milliseconds, and then we treat ARM like anyone else. Does it make sense, Rishi?
yeah.
Kids, did you understand what I was saying there?
Yeah.
So what I'm saying is,
Yep.
let's go to here. When we say go home, guys, ARM.go home, let's have this guy sleep. Okay. So this is the problem we are actually facing right now. When we ask it to go home, it is, you're setting the position. It will eventually come there, but we are not waiting. So do we know how long it takes? Rishi, do we know? Is it a second or 2 seconds? If you want to be, if you
Yeah,
want to
it's
be,
like a second.
1 second is good.
Yeah, 1 second, I think.
I'll wait. Wait to go home. I
Mhm.
don't know. Any better wait millis to go home?
Yeah.
Okay, so we will wait for 1000 milliseconds. So this thread, whoever spans this thread will wait, guys. Please understand that. Okay, whoever spans this thread. Now let's go here. So we have 3 runnables. Okay, what I want to do this, guys, is I want these runnables. You don't need them in the method. We can safely put them in the outside of the method as a variable. So I think, I think. Let me see if I don't know if I can do this here. Okay. Yeah, looks like we can do this. So, but what I will call this is slider thread. Okay. Okay, no problem. This one I will call it slider runnable. It is not really a thread yet. When you do a new thread, guys, this is where the thread is. Okay, I will store this in a variable. This one I will call it slider runnable. Okay, with your permission.
Yeah.
Slider runnable. Oh, sorry. What is the refactor rename is Shift F6. Okay. Shift F6. Slider runnable. Okay, for pickup. And then Shift F6, slider, sorry, elevator runnable. For pickup. ARM thread, ARM runnable. ARM runnable. It is not a thread yet. It is just you're defining what you want to do. That's all. These are called runnables. Okay. Now here, now let's create a new thread here. Okay. So I will store it in a variable. Why I will do it, I will tell you in a second. I'll call it slider thread. Okay. We'll start. Slider thread, elevator thread.
Yeah.
And then ARM thread. Okay. Now I created, 3 threads and I passed my runnable. That is how, threads work, guys. You pass that. Okay. Now we did not start the thread. Okay. We just created them. I'm thinking if we can create these also here. One time I can create the threads also here. Okay. And now I will call it. In fact, I'll call this slider thread first. I'll put all of this, for stack pickup. Slider thread for stack pickup and elevator thread for stack pickup. For stack pickup. And then ARM thread for stack pickup. Okay. Now, once I have 3 threads, now sleep for whatever the 100 milliseconds, and then start 3 threads, all of them. So start this guy, and then start slider guy, elevator guy, arm guy. Okay. Okay. Now these 3 things are happening in parallel, right? Okay. Now, guys, we want to wait until all the 3 things, these 3 things are running in parallel at the same time, and you are the police guy, and you want to make sure all these 3 are fully complete before you do your pickup, the grabber.pickup. Does it make sense or no? So how I do that is there is a better way than storing it in a variable. So you can do this thread. Okay, this thread dot thread, each thread has a method called alive. If this thread is alive, that means it is still working. It is still working. So if a slider is still working, or elevator is working, or arm is working, if either of them is working, go sleep for 50 milliseconds. When you say go sleep, your main thread is sleeping. Your main thread is sleeping for 50 milliseconds. Does it make sense? And then it will go back and then say, hey, slider, are you still working? Okay, slider is done. Okay, elevator, are you still working? Yes, I'm still working. Then go back to sleep, no problem. And then it will go back to sleep. And then it will ask again after 50 milliseconds, slider, are you done? Yes, I'm done. Elevator, are you done? Yes, I'm also done. Arm thread, are you done? No, I'm not done. Okay, sleep for another 50 milliseconds. Maybe next time, this is I'm done. Is alive? No, I'm not alive. I'm done. Are you alive? No, I'm not alive. I'm done. Arm thread, are you alive? I'm not alive. I'm done. Then you get out of this. Once all the, if all these 3 are not alive, okay, that means if all of them are false, then it will go here. And now we don't need to do arm.go home again. Rishi, please correct me here. You don't need to do this one anymore, because that is what your arm thread is supposed to do. Agree?
Yeah.
Now all you need to do is elevator dot now. So elevator thread dot, why do you need to do this one? Go to stack pickup. I thought that's what elevator thread is supposed to do. No.
The elevator thread for stack picks up gets it ready to go down. The issue we had was that when you went all the way down, because we already instantiated the thread, it wouldn't update each time we reduce the number of cones in the stack, because we already built it.
So what you are saying is these 3 things are happening in parallel here. Elevator's job is only it's preparing to go down, preparing for pickup, meaning it will, what do you mean by prepare for pickup here? Prepare for pickup, get prepare for pickup. Okay. Essentially prepare for pickup is 533. So it's doing so many ticks going down. Okay, but it's not fully going down to pickup, is what you're saying, right?
Mm-hmm.
Okay, fair. And now after all these 3 guys are done, fully done, now in your main thread, now you're going to stack pickup, right?
Yes.
Okay, fantastic. So elevator dot go to stack pickup. Now number of cones left in stack. So number of cones left in stack. Number of cones left in stack. Who owns this one? Currently, red right has this number of cones left in stack. So now this additional cone dropper can have this this variable. I think. Let's see. What do you guys think?
Yeah.
This additional, the number of cones left in stack can be maintained by this additional cone dropper. Okay. And then every time you call, I will maintain. But the only thing is, you don't want to instantiate me several times. You want to instantiate me once, and then okay, I think let's leave it here, and then let's see what happens. Elevator dot go to stack pickup. Now it will go to that. Now wait before pickup. Okay, you go to stack pickup, and now you want to wait before pickup. Okay, fair. Wait before pickup is let's bring this guy also into this one. Wait before pickup. Okay, you waited for so much, and then you were saying grabber dot pickup. Sure, we don't have a variable called grabber. Okay, let's get the grabber. Private grabber. Hey guys, I know I'm going fast. Kids, all the kids, you know, I know I'm going fast, but are you guys following it, or is it crazy? Yeah. Are you guys following it?
Yeah.
Yeah.
Okay.
Yes.
You know, we did this
Yes.
exercise a lot of times in the past, so that's why I'm going fast. Okay. Okay. Now, after these threads, we are checking is alive. Now we don't need to see the beauty. This one, Rishi and kids also watch me here. Now I don't need to do this.
Yeah, I think that cleans it up a lot.
Okay, that cleans up a lot. Exactly. So grabber.pickup, and then as soon as I picked up, I updated my variable because I picked up one. Now in the cone stack, I only have one less. Okay. Now wait after pickup. Wait after pickup. Do I have a wait after pickup? Okay. So there is another variable called wait after pickup here. I'll get that. So I got the wait after pickup. Very good. Now, so I grabber picked up the cone, reduce the number of reduce the variable with the number of cones left in the stack, and then it's sleeping for a few milliseconds. And now we picked up. Now we need to drop that, right? Again, we have to do the same thing. We need 3 runnables and 3 threads, right? So let's go back and let's pull all of that information here. So what are the 3 runnables, guys? Elevator thread for stack drop, arm thread, slider thread. Okay. Elevator thread, arm thread for drop, slider thread, elevator thread. Okay. So let's take out all these guys and put it into these variables, into separate runnables. I will put slider elevator arm, right? So I'll put it in the same as slider elevator arm. I'll put them in the same, kind of order. Slider thread for stack drop. This one I'm renaming it to slider runnable. Slider runnable for stack drop. Elevator runnable. For stack drop. Arm runnable for, arm runnable. Shift F6. Arm runnable. Okay. Now let's take a look at it. Slider runnable for stack drop, new runnable, go home. See, I don't need that variable anymore. Elevator thread is working, false, all of this, I don't need it. Now, elevator runnable for stack drop. This one needs a junction level, okay? Junction level, this is always medium, right? But I can go to I can directly ask read write dot, I think read write dot junction level. So I'm going to read write itself directly, and then on position. Yeah. So I'm depending on read write now. I may not like this much, but we'll see. We'll see. Okay, we have 3 runnables now. Let's create 3 more threads now, like how we created here. Let's create 3 more threads. These are the threads. Why did we create 3 sleep 300 milliseconds here in between, Rishi?
Oh, it's so then we wouldn't knock over the stack. Because we needed to go up a little bit before we started moving.
So you are starting the elevator.
Yeah, so it'd pick it up because if we just did them all at the same time, then it would knock over the entire stack.
So we picked up now. What does elevator drop will do? This one is going, it's essentially going up, right?
Yeah.
Okay.
So we let it go up for a little bit before we start moving it forward and back.
Because if we start moving before, it'll tip over the stack.
Yeah.
Okay.
So I would like to understand here, elevator runnable for stack drop, essentially, this one is directly going to the junction level, which is going up all the way, right?
Mm-hmm.
Right. So
Yes.
it is going up, okay, going up to the junction level. After this, so you think while going up, we can, arm and slider can't go?
No, yeah. No, it's not doing it one at a time. It's just it needs to go because if we just move them all at the same time, like let's say this was the stack, we move them all, we tip it over. So we go up a little bit and then we continue doing it.
Gotcha. Do you want to, if it's the right thing to do, if elevator moving up, if we don't want this to be running in parallel, what we can do is we will take out this thread, we will run this guy in the main thread itself, okay? Meaning,
well, we don't have enough time to do them one at a time.
no,
So
I'm
it's
saying
not-
only elevator we can do it separately, and then arm and slider can go in parallel. If that's
But if you see how it's doing, we're not actually taking like the full time. We're just waiting like one third of a second just to let it go up a little bit. So then the other ones can start working in parallel. Because if we do them separately, I don't think we'll have enough time at the end of the program.
Gotcha. So this is after pickup. We don't want, okay, I see. Because arm and slider, if slider moves immediately back, then yeah. Let's go to this runnable here, and then okay. I'm okay. I'm okay. I'm okay. So let's put these 3 threads here, guys. I'll take out this layer. Oops, sorry. Control Y. Okay, so let me create now new thread. This one we will call it elevator thread for stack drop. Okay, because this is the real thread. Elevator thread for stack drop, and then arm thread for stack drop. Thread for stack drop, and then slider thread for stack drop. Okay. Okay, we created 3 runnables and 3 threads on the top now. Now let's go here. So elevator thread for stack drop, start, and then give 300 milliseconds. Okay. After this guy starts in parallel, you are pausing. So your arm and slider, they don't start immediately to the point that Rishi was saying, right? So now after 300 milliseconds, we do arm and slider go in parallel. Arm and slider go in parallel. Okay. Now, so here also now let's take a look at arm for preload drop. What do you guys do? Arm dot move. Is there a, so here also arm dot move. Shall we put a sleep here?
We could just move the sleep into that. Yeah,
Yeah, because
I think it makes it look a little nicer. Plus, if we wanted to adjust them individually.
wait millis to go. Wait millis to go to position. I mean, I know it's a same 1000 at this point, but okay. Now
You
what we're
think
doing?
thousands too much?
Good point, Anish.
I mean, we can always test. Like,
Because like right now, we're having like exactly 1 to 0 seconds left.
We were actually playing though. I remember one of the matches, we didn't park before the bell ended.
So the only shall I say something one shall I make one comment there to both no Anish, Madhu, everyone? Let's test it, and let's start with +2, cone +2, the preloaded +2, and then see how accurately we are doing it. If it's okay to slow down, and let's see if we'll come back and cut the fat again. What do you think? So, hey, one thing, tell me here, arm is 1 second sleeping, right? Anish, take a look at this one. Arm thread dot start and slider thread dot start, right?
Yeah.
Arm, we are sleeping for 1 second. Don't you think slider will take a second for to go to dropping position, man? Doesn't it take 1 second? All the way from there to to the drop position. By the time this will come back, your arm is sleeping for 1 second and slowly it will come to its position. I think it's very safe, Anish. Do you guys agree with that, kids? Rishi, what do you think?
no, I think 1 second. If it's too much, if we are seeing that it's pausing too much at the end, we can change it.
Yeah, but take a look at it. This is sleeping for 1 second, but slider is running in parallel. Don't you think slider will take at least a second to come back to
Yeah, I think so.
drop position?
Yeah, I think a second's a very good number.
So yeah, I think so. So let's see. So again, we do the same thing while elevator thread for stack drop, if it is alive, okay. If either of them, if any of them, if three things are working in parallel, elevator is working in parallel, arm is working in parallel, slider is working in parallel. Of course, elevator got a little bit of head start.
Hey, uncle, do you think we could split this program? You know how we have the one method pick up drop? Do you think we could split this into two? One method where it says
I think so. that's where kind of my head is kind of going looking at this class, because a lot of junk
Because I
has
think this
been,
is also starting to get a lot.
yeah, you know, we will do that. See, that's why you don't want to do the whole refactoring in all in one phase, Rishi. You want to do it in a phases.
I see.
Okay,
So
always
it's not too overwhelming.
exactly, because you don't want to dig that rabbit hole where you don't know how to come back. I did
Wow.
that. I did that. So if we'll do that in the second phase. If slider is alive, or elevator thread for stack drop is alive, or arm thread for oh, did I say preload drop, guys? Oops. Stack drop, right? Oops. Arm runnable. Did I copy the wrong one? Yeah, I picked up the wrong one. Arm runnable. Do we have an arm runnable? Okay.
But doesn't like
So
the
looks
preload
like it
also
is the
drop in the
same.
same area?
Looks
Yeah.
like it is same. That is why. Okay. Okay. That's fair, buddy. Yeah. But I'll rename this one. Arm runnable for stack drop. Yep. Looks like it's the same for both of them. I'll call it stack drop. Yeah. Arm runnable for stack drop, and then arm thread for stack drop. That was a good point. Yeah, arm thread for stack drop. Okay, go back now. Slider is alive, elevator thread is alive, arm thread for stack drop is alive. If either of them, if any of them is alive, then hey, main thread, go back to sleep, because not everyone is done. If all of them are done, then pretty much what we're doing, we are dropping the before release, elevator, we are dropping a little bit, and then grabber is releasing it, and then doing a lift after release. That's it. What do you guys think? This is beautiful, right? I know it is still doing a lot of things, but I think it's a great first start. Okay.
Yeah, I think so too. I think this is gonna be a lot easier to.
Yeah.
Less complicated.
Absolutely. So going back to Kent Beck's quote, first make your change easy, and then make the easy change, right? I think we did pretty good job there. So let's go back and fix all the compilation errors here. Okay, so I don't need the slider thread working, elevator thread working, arm thread working, all this junk. Elevator thread for preload drop. Okay. I can even move these. I will also call these elevator runnable. Okay. Rather than calling, I'll call it elevator runnable. Oh. Okay. Elevator is not there. Okay. Okay, elevator runnable. We got the trajectory sequence, everything, elevator thread. Okay, grabber dot pickup. This is all initialization. What is this? After grabbing that pickup, we are doing a 2-second sleep, huh? Why are we doing 2-second sleep here? I don't know. During initialization?
Yeah, that just allows it. It's a lot easier when instead of going up at the same time, it just like waits 2 seconds. So I can just like leave it, hit in it, it'll pick up, and then after 2 seconds, it'll just rise a little bit.
Okay.
Just so then we have time.
Sounds good. Fantastic. Yeah. Check if you need to hold the elevator from dropping. What is this? If while hold elevator for text. I think this is working pretty good, right?
Yeah, it is. We can get at that to do.
Agree with you. So this whole thing is initialization. And then once we start, scan, get the parking position, and then elevator thread free for preload drop, arm thread. Okay, I will get that arm thread. Where is that arm thread? So elevator. I will rename this one to match our naming standards. I will call it elevator runnable. Okay, guys. And this one I will call it arm runnable. Oh, arm runnable for preload drop. Okay. So this is elevator runnable, arm runnable. Okay. After you start parking position, get the parking position, elevator runnable, preload drop, and then arm runnable for preload drop. Both the threads will start at the same time, and then drivetrain will follow its trajectory, and then elevator will drop before its release the preloaded cone, and then lift a bit. Okay, that's it. Guys, after lifting a bit, and all we need to do is pretty much call this additional cone dropper. So this is what we'll do. Let's do our additional cone dropper. We created a new class now, additional cone dropper, right? So we will instantiate that. How do we do that? We will do it somewhere here. Additional cone dropper equal to new additional cone dropper. And then what does it take? Does it take hardware map? I think so, right?
Yes.
Yep, it takes hardware map.
Well,
And now after we start, go ahead, Rishi, you're saying something?
no, nothing. Never mind. I thought something was.
So after starting, get the parking position, start your elevator thread, and then start your arm thread, start your follow your trajectory, and then drop before release, grabber release, and then elevate, lift after release, and then pretty much additional cone dropper dot pick up and drop additional cone. Okay, we'll call one time, we'll call two times, we'll call three times, and let's do only three times. Okay, are you guys okay with that? Because we can add this line of code anytime. And in fact, we can loop it, as Vishal was saying earlier, or Anish was saying, Vishal and Anish were saying. So see this one, guys. Once you refactor and move all the junk into junk, meaning, and I don't mean really junk, but all that logic into a single method, it came down to one line of code, guys. This is what I mean by first make the change easy and then make the easy change. Making the easy change is piece of cake. Does it make sense? Now I can remove all these lines, second additional cone start, all this. Third one, I can remove this, and fourth one, I can remove it. Guys, do you guys agree?
Yeah.
Sleep, wait for pickup, all of this. Remove. That's it. And then park the robot. What is this one, buddy?
Just to reset the arm back to home so it doesn't cross the barrier for parking.
Good point. So now park the robot. Can you say that again? Reset
the arm so it doesn't cross the barrier.
Yep, reset the arm to arm position. Reset the arm position so that it will not cross the
parking barrier.
parking barrier. Okay. Something like that. Okay. So ARM thread, ARM runnable, I think. ARM runnable for preload drop, right? Is it right?
Hmm.
Yeah, right?
Yeah.
No, because you want to, this is ARM runnable for preload drop. This is preload drop. Preload drop, what will it do? It will move. But here we are going home. Now we need one more ARM runnable.
Don't we have an ARM runnable for preload pickup?
We do have, buddy. We do have ARM runnable for stack pickup. This one, right?
Yeah.
ARM runnable for stack pickup. So since in this context, in this class context, shall I call this one as ARM runnable for ARM runnable to go home? Any objections in that? So that it will know, because our intention is not, it's not clear there. Our intention is to go back to home, right?
Yeah.
ARM runnable to go home and start. So now I will understand, when I read this line of code, I know that my intention is to go home, to go back, right? ARM is to go home. And then I have a nice comment here. Okay. So this is happening in parallel again in a new thread. While ARM is moving, going home, I will park the robot. Is it fair?
Yeah.
Yeah.
Okay.
Yep.
Ooh, see, your class came down to 115 lines of code. That's it, guys. It's that simple. Your life is that simple. You have a couple of runnables, and I mean, if you want, you can create these threads above also. And then say. So, well, what I'm saying is, you can, by creating a thread, there is no problem. Well, what I'm saying is, for example, elevator, right? So you can safely do it here. No problem. Thread elevator thread for preload drop equal to new thread of elevator runnable. All you need is a runnable, okay? Yeah, runnable, and then you just have a thread to support that. And then you can do it. Here you can do a thread.start. Do you guys want to do that? I think that's probably even more readable. So you are creating a runnable and thread, runnable and thread. That's always the combination. So what I'm saying here is, I will show you what I'm saying. This is the runnable. This is the thread for that. And now thread thread for preload drop equal to new thread. That's it. And then probably one more thread I need. ARM runnable to go home. Now I'll call this one ARM thread to go home. Now, so you are creating a runnable, you are creating a thread. Creating a thread does not mean it is happening in parallel. No, you have to start the thread. That is when this, whatever is inside this run method will go happen in parallel. Does it make sense, guys? So now I'll come back and say, I will say elevator thread for preload drop, elevator thread for preload drop dot start, ARM thread for preload drop, ARM thread for preload drop start. So you started these two things in parallel, and then you started your drivetrain, and then dropping your elevator before release, and then release it, lift it, and then additional cone drop 3 times you do that. And then now go home thread will start. We are calling that as arm thread, something like that, arm thread to go home, arm thread to go home, start the thread. And then while it's doing this one, every time you do it, some thread dot start, that means it is happening in parallel. It will not wait until this is complete. It will go directly here. Does that make sense or no? Guys?
Yes.
Fantastic. You say go home. Yeah, I think that's it. So now we can go make any changes pretty easily because we refactored everything and made our life easy. Okay. So Rishi's point is that Rishi was kind of saying that, uncle, pick and drop, we're doing it in the same method. Can we do pick up in one method and drop in another one, so that we can, you can go to any extent. In fact, you can additional cone picker, you can say, you see what I'm saying? Additional cone pickup one class, additional cone drop another class, and then you can do that. In fact, I like that idea. We will do that in the second again, another phase, but let's test it. Rishi, what do you say?
Mm-hmm.
So let's test it. Oh, in fact, if you guys don't mind, I will add this runnable and the thread right before it. So for example, slider thread for pickup, right? I will put this one runnable and thread in the same combination. Elevator runnable for stack pickup, and then elevator thread for stack pickup. They go as a pretty much pair. Arm runnable for stack pickup, and then arm thread for stack pickup. Okay. And then slider runnable for stack pickup, and then slider thread for stack drop, sorry. Slider runnable for stack drop, elevator runnable, sorry, slider runnable for stack drop, slider thread for stack drop. And then elevator runnable for stack drop, elevator thread for stack drop. Arm runnable for stack drop, arm thread for stack drop, like each pair. And now number of cones left in the stack is controlled by this guy. So only one suggestion I want to give you here is, you don't want to do this, this additional cone dropper. You want to do this multiple times. You don't want to do new additional cone dropper every time, because every time you do new, your number of cone stack will be reset to 5. Does it make sense? So that's why you do this instantiation once and then call any number of times. So Lokesh uncle has been saying, hey guys, test it with 2 cones. Please test it with, just take out this line of code. That's it. Only two additional cones. Let's see how consistently we are doing it and how many seconds left. And then come back and add 3rd line of code, 4th line of code. Can we start with two cones, or you want to start with 3 cones directly? I mean,
We can start with like whatever you want. I mean,
it's one line of code.
Yeah.
Oh, to Rishi's point, you can even start with no cones also. Yeah. So, okay. Hey, okay, this is the midway, no? Where are we using this midway? Oh, there. Okay. So this is the, okay, your starting position to midway to cone drop position. Okay. Okay, how do you guys feel? Let me stop sharing, and before that, let me go ahead and commit. Additional cone dropper, we introduced arm, we introduced elevator, we did it. Red light, red right, we do it. Okay. I'll call it major refactoring after. We did decent refactoring, major refactoring after Okra. Actually, major
It
refactoring
was
around
meet 6.
around additional code dropping. I'll call it. It doesn't matter once. Okay. So let me stop sharing now. Can you guys unmute and share your thoughts? What are you guys doing? I mean, what did you grasp? How was it? How do you like
It
it?
feels a lot easier to make the changes now because it's in a separate file and one change will change it to everything.
Another thing is, before it was really complicated. Now it's really easy to see what's going on.
Anyone else? Sia, did you follow?
Yeah.
Jitin? Madhu,
Yeah,
what do you think?
I just think it's a lot more organized.
More organized. Gotcha. So you think you can manage now?
Yeah.
Okay. So do a git pull and when are you guys? When do you guys want to test it? Do you, hey, Rishi? Do you think you guys are off tomorrow, right? You're going to Canada tomorrow. So is there a way we can test this this quickly?
I mean, yeah, Sai, you can test it tonight, right?
Let me stop recording.